about using the square of a binomial pattern. You can see here, the diagram over here is kind of a visual representation. You have a plus b on the left side to give you that length, a plus b on this side to give you this length, right? Think area of a square. Okay, I'm gonna have to write this on the board because y'all are not. Yep, we're gonna do it on the board. Add a picture so people can see this. Okay. Blank looks mean I need to draw. All right, so if I have a square and you want to find the area of this square, right? What is the formula to find the area of that square?
Length times width.
Yeah, length times width. If it's a square, it's just the same thing. Like 4 times 4. Like say this is 4 and this is 4. To find the area of this, you do 4 times 4, which is 16. That all makes sense, right?
Yeah.
That's elementary school. Cool? All they're doing is breaking it up now. So what they're saying is if I were to break this piece here and then this piece here, tell you the length of that is b and the length of this is b. The length of that is a, the length of that is a. So far so good?
Yeah.
The entire length of this is just b plus a, right?
Yeah.
The entire length of this is just b plus a. So if I were to write that as a formula for this times this, I would say b plus a times b plus a. So far so good, right? This is simplified to b plus a squared.
That makes sense.
Does that all make sense?
Yes.
You're a little annoyed because it kind of makes sense?
Oh no, I heard them yelling, shout!
Of course. But yes, makes sense?
Yes.
All right. So what they're trying to show you is that if I want to find all parts of this, okay, you're going to have to rewrite this equation as you see there. So it's this again, b plus a times b plus a, and we do the FOIL method. Okay, so this would be b times b, which is just, okay, b times a, which is just ab, a times b, which is just ab, and then a times a
squared.
which is a squared. Does that look like the same thing they have there?
Sure.
We can simplify this middle. If I have an ab plus an ab,
2ab.
then I have 2 ab's.
Sometimes it gets confusing for me to do the 2ab or ab squared.
So when you're adding, you just, you have 2 of them. If you're multiplying, it's squared. So it's addition versus multiplication. But yes, you have to pause on those things sometimes to help you. All right, everybody understand that pattern-ish? I understand it's kind of complicated looking.
That's for me.
They're homemade. Yes. Thanks.
I even want it for you.
Oh, they're so nice.
Wow.
You didn't even look at my math. It's all kinds of exciting today.
I have no desire to, but I love you.
All right. So that's called the square of a binomial.
Is that good?
Oh, yeah.
You have no desire.
I'm going to move my face and hide this. All right, so all they did over here was a actual version with numbers. So let's do that. I want you to write. This needs to be in your journals, this part.
I heard that.
Good, excellent. And then I'm going to do the number version. If the visual of the box helps you, you might do that in your journals. If it doesn't, that's fine too. The box never helped me, but it helped my sister. So
I think.
I like the box, like the method, the box method, the one that we did like 8 times 8. I don't know.
totally fine. I hate the box method, which is ironic.
I like the
Y'all, you pick which one you like and do
I'll
it.
do both. I
Yeah, I like FOIL. All right, so let's practice this one. So I have x plus 5 squared. So what's the first thing I do to solve this, to simplify this?
You do x squared plus 5 squared.
Nope.
Okay.
X plus 5 times x.
Yes, we need to spread it out. So x plus 5 times x plus 5. Eventually, you will recognize this as the square of a binomial, and you'll know how to get from here to here without doing FOIL.
Oh wow.
I know you don't believe me, but I promise you'll be like, oh, this and this and this, and just does, and you'll be able to do it in your head.
Yeah.
But let's do it out loud. So FOIL, we have x times x, which is
X squared.
And then we have x times 5, which is
5x.
And then 5 times x.
5x.
And then 5 times 5.
25.
Could I also have written this as 5 squared?
Yeah.
Yeah, you could. No reason to,
Oh,
but you could.
did on the concept.
Well, we're going to solve it, so it doesn't matter. All right, what's the last step to simplify this?
Like terms.
So we're going to combine like terms. 5x plus 5x is
10x.
10x. So then this would be the completely simplified version. Now you see why I box my answers my whole life instead of circle them. Because box is pretty.
10x, and I need some Kleenex.
All right, let's do one more with a coefficient in the front. So if I have 2x minus 3 squared, scoot this over so online people can. I think it's backwards online, but c'est la vie. You get the gist. Oh, real quick. So you notice here how you probably could do this in your head because it's pretty simple math, right?
Mm-hmm.
You x squared, then you know you got to do 5x plus 5x, so you knew it was 10x, and then 5 times 5 is 25. See how you could probably do that in your head now? But let's do it with a harder one. So what's my first step here?
You write it into 2x minus 3 times 2x minus 3.
Yep. Yeah, the way they wrote it's weird looking. I would never do it that way. So we're going to do it this way. So 2x minus 3 times 2x minus 3. And as you guys go through high school, you're going to have algebra teachers that teach you different ways to solve this stuff. You pick which one works for you. So learn theirs and then remember this one and go, I like this way method. Doesn't matter. There's more than one way to solve things often. All right, so we have 2x times 2x. 2 times 2 is?
4x squared.
Very good. Then we have 2x times the negative 3.
Negative 6x.
Very good. Enter.
Negative 6x.
And
Positive 9.
last. Negative times a negative is positive, and 3 times 3 is 9. The last thing is combine the middle, so we have 4x squared. Negative 6 minus 6 is further negative.
Negative 12.
Very good.
Thanks.
Any questions?
Yeah. I can't get myself into the habit of doing the boxing answers because Miss W drove it so hard.
Oh, yeah, whatever you have is fine. Just making sure you're identifying what the answer is all your teacher needs. Okay, now let's do an actual example. I know we just did 2, but I want to make sure you guys get this. All right, so we're going to find each product. So let's do A. Write this in your journals. We have 3x plus 4 squared, so gross. They're doing the square of a binomial pattern. I just want to see if I like this. Hold on. Yeah, I don't like the square of a binomial pattern. You can use it if you like it. Because you know the first one is 3x squared. Oh, yeah, see, I don't like it because it's too easy to make mistakes. Because you might not put that in parentheses and then you forget to square the 9. You might not, yeah. I love you. Don't do that way. That's going to be hard on you. Let's not make it harder. So we'll do it my way. All right, so we have 3x plus 4 squared. So I'm going to go ahead and skip that step and do 3x plus 4 twice. All right, according to FOIL, 3 times 3 is?
9x.
9x squared. 3x times 4.
12x. 12x.
And then 4 times 4.
16.
Combine.
24x.
Any questions?
No.
See how much faster that was? Then I don't know whatever they were doing. See, I promise you guys can do this. All right, let's look at 5x. Ooh, we added a variable. 5x minus 2y squared, right? So I'm going to write it again. 5x minus 2y. All you need to do when you have two variables is take your time. Because you just don't want to rush and make a silly mistake, okay? So, according to FOIL, we're doing 5x times 5x, which is x squared. And then 5x times negative 2y.
Negative 10xy.
Excellent. Why is it xy?
Because you times x and the y together.
Also true. And it's
Oh, yeah,
in alphabetical order. So always put x, y, z, and put it in order. That's why we do A, B, no matter which one was there first.
I wonder how the alphabet felt after it felt left out with dropping the numbers with the numbers.
It takes over. All right. Then we do negative 2y times 5x, which is
Negative 10xy.
negative 10xy again, and then negative 2 times negative 2y.
Positive
4y.
Positive 4y squared, because there's two y's. And you're multiplying. All right, simplify the middle. So we have 25x squared
minus 20xy.
minus 20xy plus 4xy squared.
4xy squared?
Yes. Nope, I said x randomly. 4y squared. I was like, yeah. There you go. Did we get the same answers that they did?
Yes.
Yes. Was it a lot less confusing? Maybe a little. All right. Now you're going to go do monitoring progress 1 through 4. All right. So this is going to help you recognize patterns. The sum and difference pattern. So when you find the product of x plus 2 times x minus 2, you can do that by using FOIL, which you see here they did. Oh, that pulls the whole thing. So they did FOIL, which is x squared minus 2x plus 2x minus 4. You notice they come out with x squared minus 4. So this is a pattern that you will see in polynomials, binomials, that you can recognize, and then you don't have to do the FOIL. You just go, oh, that's the sum and difference pattern. That's the sum of difference. So you can see here, this is what I want you to write. Sum and difference pattern is this. So when you see this, going through it, a plus b, or whatever the number is, you can just automatically write it as the first variable squared minus the second variable squared.
What?
I'm going to go over the example. I'm waiting for you to write the concept. So for instance, over here on the example, everybody look up here, I have the difference of squares, right? X plus 3 and x minus 3. Do you see that? So I know that that's the difference of squares, right? We have a plus and a minus, and everything else is the same pattern, correct? Same. It's like saying the same base number. We have x for one and 3 for the other. So I know that this is the difference, the sum of difference pattern. So then I can just write x squared, and then you do the b variable, which is 3 in this case. 3 times 3 is what? 9. So it's a way to skip doing the FOIL method,
But
because you're just recognizing the pattern that would happen if you did the FOIL method.
But we did.
Okay, don't talk with that much cracker in your mouth. Question? Are you done chewing?
yes. What about 3x minus 3x or whatever? Like
It only works if the first one is plus and the second one is
cancels
negative.
out.
Correct.
Okay.
Because those two middle numbers cancel out.
Be like a 3x minus.
It'd be a, yeah. Question.
So, what? So if we don't recognize that it's that,
You can do the FOIL method and you will get the right answer.
okay.
Great question. I'm terrible. It took me 20 years to recognize this for some reason. I just don't see it. So when I see this up here, I just FOIL it and move on with life. It's faster for me than trying to remember a pattern. So that's totally okay. Yes.
Why is it -9 and not -3 to the power or squared?
Because the first one is a positive and the second one's a negative, and a positive times a negative is a negative.
Yeah, but why is it 9 and not 3 squared?
Well, it can be 3 squared.
Okay.
But we simplify it all the way down, which makes it 9.
Uh,
Great question. Yes, ma'am.
Does it work the same if there's minus as the first one and the plus is the second one?
Technically, yes, because you could rearrange those.
Okay. So it doesn't matter.
And not really. As one is positive, one is negative. It would still work. Perfect questions, you guys. Good job. All right. So I'm going to show you an example. Write this in your journals. All right. So looking at A, is this surprisingly the sum of the difference of squares? Yes. So looking at this, I know I can go t squared minus 25. Does everybody agree?
yeah.
Wait, we're on example 2, right?
Yes. And you can see here how they originally wrote it as 5 squared and then simplified. If you want to do that to help your brain, feel free. If you want to skip straight to the 25, that's fine too. The biggest thing to remember is it's a negative. Don't forget that part. All right, ready for the second one? For B? So again, is this the difference of squares? Yes, they're just more variables. So we're going to do 3x times 3x, which would be 9x squared. And then what's the second one? Minus y squared. Do you agree with him? Good, because he's correct. Make sure you wrote it in your journal.
Okay.
Starting to make more sense?
This one makes a lot more sense than the other one.
Yeah, this makes more sense than the way I was taught, because I will probably recognize the difference of squares now going with this textbook rather than the one that taught me. Excellent. All right. Example 3. So we're going to use our special products patterns to find the product of 26 times 34. So we're going to use one of the rules we just learned, which basically means we're going to turn this into exponents. All right. So looking at this, you know that 26 is 4 less than 30, while 34 is 4 more. You see that, right? So you can write this as 30 minus 4 for the first one, 30 plus 4 for the second one in the parentheses, right? Does that still equal 26 times 34? Yeah, because if I subtracted this, I'd get 26, and I added this, I'd get 34.
Oh, that makes sense.
Yeah, it seems counterintuitive to make the math more difficult, because most humans would go, well, what's 26 minus 34? And they just do it. It's recognizing patterns, number one, which is important for math. And number two, it's teaching you how to, when you get the big, huge equations with all kinds of variables, there's different ways you can manipulate the numbers to be able to solve the problem. So it's helping you recognize to look for the out of the box solution. So now we have this. Do you see that this is the difference of squares? Because one's positive, one negative. They have the same base number, essentially. So this would be 30 squared
900.
minus
16.
4 squared, correct?
Yeah.
This is how you solve math without a calculator. 900 minus 16, which is?
Why would we do that?
Oh,
Yeah, welcome to the dark ages. We didn't have calculators.
884.
884. So the product of 26 and 34 is 884. Now, can any of you do 26 times 34 in your head? No, you need a calculator, right?
I mean,
Could you?
could.
It would take a while. Could you do the 30 squared minus 4 squared in your head?
Yeah.
Yep. Because you easily all went 900 and then 16, and then you would go, oh, I need to subtract that, 884. So this is a way you can do some of this multiplication in your head.
But also I'd be like, okay, 30
All right.
squared.
Monitoring progress 5 through 8. Go team, go. Shh, last example. Last example.
I think she's telling you to get it.
Example 4. Oh, this is science. A combination of 2 genes determines the color of the dark patches of a border collie's coat. An offspring inherits 1 patch of color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. The gene B is for black patches. The gene R is for red patches. Any gene combination with a B results back in black patches because it's the dominant gene, the capital B.
The dominant
Allele.
allele.
It's allele.
Oh.
Suppose each parent has the same gene combination BR. The Punnett square shows the possible gene combinations of the offspring and the resulting patch colors. What percent of the possible gene combinations result in black patches? 75%. That was easy. Why? Because it's 3 out of 4, 75%. Yeah. Show how you could use a polynomial to model the possible gene combinations. No, look at this pattern, guys. We have our over here. We have our first number, which is something squared. So would that be BB? B squared. Okay, and then the middle is the BR plus the BR. And then the ending is the R squared, correct?
Oh, that makes sense.
Oh. Okay. So you have the B squared, which is 0.25% because there's 1 out of 4 squares. And then you have 2 of the BRs. So they added together equal. Oh, so they're doing the square pattern that I don't like.
They're intriguing.
I like this. I'm going to write it because yuck.
No, like science.
My Chromebook's gonna die.
All right, so we have the big Punnett square, which is BB,
Yeah.
right?
Yeah.
So 0.5
Sorry.
equal model the gene from the parent. And then plus 0.5 R. So you get half from the dominant and half from the recessive.
Heard.
Okay? So then if I were to write this, I would have 0.5B plus 0.5R. Oh, because this was squared.
Yeah.
Forgot to write that. And then again, 0.5B plus 0.5R. And then we could FOIL. So I get 0.5 times 0.5, which is?
0.25 squared.
B squared.
Oh yeah, B squared. I knew that.
Okay, and then do outer. 0.5 times 0.5.
0.25.
BR.
0.25 BR. Inner. Same thing.
Word.
And then outer. What's 0.5 times 0.5?
Wait, last.
0.25.
And R squared. Okay, and then we just combine this middle section.
0.5. BR.
It makes sense, but I don't like it.
It's okay. You're not required to like it.
Yeah, this says how I feel. BRO.
Bro. All right, so you have a 25% chance of having only black patches. You have a 50% chance of having only black patches, so you would add those together, which gives you a 75%, which is what we said to begin with, right? And then you have a 25% to get red patches. So when these dogs have puppies, it's more than likely going to have black patches. But there is a recessive gene. This works with your eyeballs too. Brown eyes, blue eyes, green eyes. Same thing.
That's nice.
Wait, so what would the polynomial be?
This thing.
That whole thing?
Yeah.
It'd be 3, right? The trinomial, right?
I quite like
Oh, wait.
I don't.
Right?
Very good.
Dude, that's the only lesson I actually understood.
Oh, you only have one more monitoring progress. Number 9.
Let's see.
Can you go back to that example?
Oh, it's the same thing, just black, gray, and white. Boom.
Can you go back?
Can I go back? I can do that.
Thank you.
I don't.
So when you're done with this, just go do your last monitoring progress.
I can go through it, please.